Welcome to online school, and let's get to section number 2. In section number 2, we have differentiation of functions from first principles. And then what does this mean? This refers to the use of algebra to find the general expression of the slope of a curve. And then the other person can also say that this refers to the use of algebra to find the general expression of the gradient of a curve. And then we also have that it is also called the delta method. And then below here, I've listed the steps for differentiating from first principles. Then we have the first step as add small changes in y and x. That is, change in y and change in x respectively. And in this case, the changes, they are denoted by delta y and delta x. And so what does that first step mean? It means that if at all we have our function is y, so we have our function which is y equal to f of x, then we are going to add small changes, and that is, it will give us y plus change in y. It will equal to f of x plus change in x. And then so this is what we have established. This is the established equation. And then after that, let's get to step number 2. Then in number 2, they are saying that subtract y equal to fx from equation in I. So this is our equation which we formed in the first step after adding the small changes. And then so let's try to subtract here. So we shall have y, and on subtracting we shall have y plus change in y minus a y, this first y here. It is going to equal to the function of x plus change in x minus this fx. And then by so doing, we have subtracted y equal to fx from y plus change in y equal to the function which is f of x plus change in x. And then this one is going to give us this expression here. So we shall remain with delta y, or change in y, equal to f of x plus change in x minus fx. Then after that, let's get to step number 3, or procedure number 3. Then in procedure number 3, we are being told to divide the expression or the function in step number 2 by changing x. And then, so this is what we are going to do. It is just that changing y over changing x. Even this other side, in this other side, we shall have the whole of this expression here being divided by changing x. So you do it on both sides. This side of changing y over changing x, even this other side, where we have f of x plus changing x minus fx, also divided through by changing x. Then lastly, to get the derivative, getting the derivative, we just take the limit of the change in y out of change in x as the change in x approaches 0. And this is how it's done. That is procedure number 4, or step number 4. Says that find the limit of the quotient in step number 3, and that is the derivative. So we shall have the derivative, which is dy dx, being equal to the limit as change in x approaches 0 of change in y over change in x. And then so this is the same as the limit as change in x approaches 0 of f of x plus change in x minus fx divided by the change in x. And so by so doing, I happen to find that we have found the derivative, and that is a dy dx from first principles. Yes, so let me try to make it clear here. We have our last expression after following all of those steps. We have our last expression as the dy dx being equal to the limit as change in x approaches 0 of the expression which we had, and that was f of x plus change in x minus fx, then the whole thing divided by divided by a change in x as change in x tends to 0. So this is what we call differentiating from first principles.